Hey everyone, how are you doing? Welcome to Practical Math, Part B. This is the second semester. We're going to be going over week one, learning how to graph and interpret linear relationships in budgeting. So here's our essential question. How can we represent the relationship between income, that's how much money you get, and the price of goods? That's how much money we have to pay for things. Here's what we're going to be doing in this video and throughout this week. We're going to talk about how to create a graph representing a budget line and calculate the trade-offs of moving along the line. We're going to represent a budget line using an equation in two variables. We're going to predict transformations of the budget line given if we have a change in income or if we have a change in the price of a good or both. We're going to actually calculate and come up with equations for budget line, and we're going to explain the meaning of a budget line in terms of personal finance. So this is where we get to apply linear equations and math with economics and understanding how to use math to be better with our money. So take notes, pause this video at any time. Again, it's about 30 minutes long, so I don't expect you just to stare at it. Pause it, think about what we're doing, write down some examples, use this video as you're doing the quiz or as you're going through assignments this week. There's an extended text if you want to read further about similar types of topics. And use this video, use the text as you're going through different things. If you have any questions, please call or email me. I'm definitely available. I want to help you work through this class and make good progress. All right. How much does it cost to hang out with your friends? Think about last time you hung out with friends. Did you go to a movie? Did you go to a restaurant? Did you just hang out? Did you go buy something together, shopping? How do you get your money? How much money typically do students have? What kind of things do students like to spend money on? These are questions that are hopefully pretty relevant to you, right? We all like to get more money, but we always like to spend it as well too. And this is where we start thinking about how to be smart with our money. We're going to investigate the expenses involved in hanging out in a problem situation designed to model the relationship between income and prices of goods. First, some vocabulary. Got to kind of understand some key vocabulary, right? When we talk about income, we're talking about payments earned, so this is money you get for either selling or renting your productive resources. So income could be a salary, right? If you're working, you're giving your resource of time and energy to work and you're getting a salary for it, wages. Interest, if you're investing money and getting paid for the money you're investing. These are all things we get. We get money from our income. A budget is a spending and savings plan. It's based on our estimated income, right? This is how much money I'm getting in, but we're using that to balance with the expenses. How much money do I need to pay for things? Do I have enough? Is my income and my expenses, are they matching up more or less, and trying to be smart with it? A budget constraint is all the combinations of goods or services that a consumer may purchase given current prices within his or her given income. So if you have a specific income, most of us aren't millionaires, and so we have a certain limits, right? There's a certain amount we can spend on housing. There's a certain amount we can spend on food, and we're constrained by that, right? We may not be able to buy the most expensive TV package, and so we have to consider and balance with the money we have in terms of what we can purchase. Finally, there's trade-offs. Trade-off is giving up some of one thing to gain something else. Maybe I buy an older car, but that lets me take trips, lets me have more gas money and spending money to go out to eat. So these are things to kind of all balance out. All right, let's start talking. Let's get an example, right? All this stuff makes more sense when we have an example. Here's our friends Pat and Sam. Pat started hanging out with Sam. They're buddies. Sam has no money. However, Sam likes his french fries. So Pat, being the nice guy that he is, he offers to ride the city bus to Sam's house. So here's Pat. He's going to take the bus. He gets to Sam's house, where Pat gets off the bus. Both Pat and Sam get on another bus to ride together to Freddy's Fry Shack to hang out. So let's switch colors. We're on a different bus. And hop on the blue bus. From Sam's house, take the bus, and they end up at Freddy's Fry Shack. There they're going to hang out, right? They're going to sit, talk, laugh, do all that kind of whatever stuff. Below is a map of the streets between Pat and Sam's houses and Freddy's Fry Shack. So bus ride there, bus ride there. All right, so let's start talking about costs. Pat must use a token to ride to Sam's bus stop. All right, so if Pat's riding the bus, gets to Sam's house for the bus stop, that's 1 token for that ride right there. Then they each use a token to ride together to Freddy's to have fries. All right, so Sam and Pat are now both going together, taking the bus to Freddy's Fry Shack, so they use 2 bus tokens right there. All right. Pat and Sam then must each use a token to ride to Sam's bus stop. So they go back up, 2 more tokens. And Pat walks Sam to Sam's house and returns to his bus stop and rides the bus back home. So 1 more token. So overall, if Pat wants to go to Sam's house, pick Sam up, go to the Fry Shack, and then both get back, they need 6 total tokens. All right. Let's keep developing this scenario here. Each time Pat or Sam gets on the bus, they must buy a $2 token. $2 per token. The price of a small fry at Freddy's Fry Shack is $1. Let's mark that down. $1 per fry. How much will Pat spend on bus tokens? Well, let's think of that. We already know to go down, pick up Sam, and then for Sam and Pat to go to the Fry Shack is 3. And then to go back to everyone's house is 3 more. So there's 6 tokens at $2 per token. Well, Pat's going to spend $12. Remember, he's the nice guy paying everything. So $12 on bus tokens. And then how much will Pat spend on the fries if each of them gets 1 order? Well, it's $1 per fry. So they will spend 2 fries at $1 equals $2. So total, how much is Pat? Pat is going to spend $12 for bus tokens plus $2 for the fries. He spends $14 for the whole entire trip. That's like their day to meet with Sam, pick up Sam, both ride the bus together, the Fry Shack, hang out, have a couple fries, and then get back. That's a total of $14 that Pat is going to spend. All right, we're kind of quantifying everything, thinking through the scenario. Hopefully you're following along with this. So we went through a single situation, came up with the amount that Pat needs to spend in order to take the bus and hang out with his friend Sam. Cost him 14 bucks. However, let's start to think a little bit bigger about this, right? Let's use some algebra, let's use some math, and look for some patterns to start to model what is happening. So here we go. We're making a nice little chart. Let's think through the situation. In the table here, the first column contains different quantities of bus tokens. So you can see quantity of bus tokens. 0 means they're buying 0 tokens, 2 tokens, 4 tokens, however many tokens they need for the bus ride. On the bottom is the quantity of French fries. So are they going to buy just 2 fries? They're going to buy 8 fries? Are they going to buy 20 French fries? It's a lot of fries. But there we go. We can start to now organize and look for patterns going on here. For example, if Pat buys 2 fries and 10 bus tokens, now we're thinking really big here. How much is he going to spend? Well, each fry is $1, so it's $1 times 2 fries. And each bus token is $2, so $2 for 10 bus tokens. That's going to be a total of $22. So we can think right here. So for 2 fries and 10 bus tokens, that would be a total of $22 in this chart right here. That's how this chart can help us organize some things. Well, what is the cost of 14 fries and 6 bus tokens? Well, $1 per fry times 14 fries, but then I add to that 6 bus tokens. Each bus token was $2 times 6 tokens. That's going to be $14 for the fries plus $12 for the tokens. It's going to be a total of $26. So under here for 14 fries and 6 bus tokens, Pat's going to spend $26 for that hangout. Maybe they're going to meet a whole bunch of people there and buy a lot of fries. If he wants to buy 10 fries, so that's 10 fries at $1 and 14 bus tokens at $2. How much is he going to spend? Well, that's $10 on French fries plus $28 on bus tickets, so he's going to spend $38 right there. So 10 French fries will be on the bottom here, and 14 bus tokens, we go up to 14. So right here in the chart is going to cost him $38. So it gets a little more expensive. There we go. We're starting to organize it. We're starting to think about a lot of different situations, right? A lot of different combinations of fries and tokens. Here's the complete chart. So this is if we went through and if we filled out every single thing. Do you see any patterns going on in this chart? Well, you may notice that there are certain numbers that seem to kind of go in a nice order, right? Look at 30, for example. Kind of a nice pattern there of 30, right? Seem to almost form a straight line. Either I can buy 14 bus tickets and 2 fries, 12 bus tickets and 6 fries, 10 bus tickets and 10 fries, and so on and so forth, right? But there seems to be a nice consistent line of 30. Well, there's also 42, 42, 42, 42, 42, 42, 42. So in our situation of fries and bus tickets, it seems like there's a lot of combinations that cost the same amount. And all those combinations that cost the same amount seem to form a straight line as well. So we get linear patterns. That just means a straight line of the same costs. We both looked at $42 as a consistent line and $30 as a consistent line. So which cells in the table show combinations, all the combinations of French fries and tokens, bus tokens that we can get for $32? Well, let's circle all of them. I can buy 16 bus tokens and no French fries, 14 bus tokens and 4 French fries, 12 bus tokens, 8 French fries, 10 bus tokens, 12 French fries, and there's our linear pattern, right? So if he has $32 to spend, if this is Pat's 32 bucks, here's all the different combinations of French fries and bus tokens that he could get with his $32. And he can now think about, well, how do I want to spend my $32? How much of each do I want to get? Do I want more bus tokens and less fries, or do I want more fries and less bus tokens? All right, so let's list out, again, we have the chart, but what are all the different ways we can spend $32 then on fries and tokens? Well, there's some things that are going to be the same. I know that the price of a French fry is always going to be $1. So right away, this is what we call a constant. It's going to stay the same. The price of the fries is always $1, depending on how many fries I get. The price of a bus token is always going to be $2. That's nice and consistent. If I'm filling out this chart, there are things that stay the same. And I'm going to kind of be aware of that as I'm looking for patterns. Now, what is different, we call variables. So think about French fries I can get. If I buy 32 French fries for $1, but no bus tokens for $2, that's going to cost me $32. All right. We can also, let's play around with this here. Remember, we have to have them add up to 32. So we could buy 30 French fries at $1. It's $32, and I could buy one token, and that would add up to $32, right? I could buy 28 French fries, 28 French fries, and I still have $4 left, so I could buy two tickets. That's going to total up to $32. And we can keep going. If you see, if I go down by 2 here, I can add another bus ticket here. So we could add 3 bus tickets, 4 bus tickets, 5, 6, 7, 8. I could keep going on and on and on. But every time I increase a bus ticket by $2, I have to decrease the amount I spend on fries by $2. There we go. So we got half of them. We could keep going on and on. But you know, as a mathematician, let's use math for us, right? These numbers are changing. So let's use a variable to represent all the different fries. Let's use a variable to represent all the different number of tokens. What does stay the same is also this $32 right here, though. So if I'm putting together an equation, then it's going to be $1 times a certain amount of French fries plus $2 for a certain amount of bus tokens, because it's $2 for each token, and we want to max it out. The budget constraint is $32. So there would be an equation. Now we're getting some good algebra going on here to model our hanging out scenario. We can use this to represent all the different combinations. So if we think about graphing it, we got a nice equation now. A little bit about graphing. If you're putting together a graph and you're wanting to show some good information, we got two variables, right? Both variables are a different axis. So French fries was our x variable. And so we're going to show that on this number line. We need to start with 0. And think about all the different combinations of French fries. It might go up by 2's, right? If he's hanging out with his friend, then him and his friend are each going to order 2 French fries or 4 French fries or 8, whatever. You're going to order pairs of French fries. Maybe we want to keep track of how many French fries we do in a month. All right, so there we can list out all the different French fry combinations. We can go on as far as we want. And bus tokens. Let's think about bus tokens. We know, let's just count by 2's in this one as well too. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So now we've got a nice graph. We've got our tokens is our y variable, because that's changing. The fries is our x variable. And now we can start to think about plotting that data that we previously had on our chart. So let's put it all together and guess what we got. If Pat only has $32 to spend, what is a budget constraint? Well, these are all the different things, combinations you could get of tokens or fries. Right here at this point on the line represents buying 16 French fries for $16, but then 8 bus tickets for a total of $16, and both those combined make 32. So the line represents all the possible combinations. And we're getting into some good algebra. Remember, the equation for this was $1 per French fry plus $2 for each bus token was a total of $32. This is the equation of this line that we're graphing right here. And there it is in table form. There's our equation, there's our line, there's our table. This is kind of combining everything that we've been doing. We made a chart first and listed off some things. We were able to make a graph of our chart showing what was going on. We used both the table and the graph to help us think about an equation of what is staying the same and what's changing, and the equation is modeling the math that we have in our table and our chart. Good stuff, right? That's what we love to do as mathematicians. Take a normal situation, like Pat spending money to hang out with Sam, and quantify it, right? Come up with a table of values, show the changes that are happening in a graph, and ultimately get an equation that helps me understand mathematically what's going on with Pat and his spending habits. Now, what if Pat's amount of spending income changed? Say he had to cut back, he got grounded for whatever reason, he doesn't have as much money anymore. Instead of having $32 to spend regularly on bus rides and french fries, he only has $20. How is this going to change the equation? How is this going to change the graph? Well, in terms of the equation, it's still $1 per french fry. So 1 times is number X, which is my number of french fries. It's still $2 for bus tickets. So $2 times however many bus tickets. But the $20 is a new budget constraint, right? It's going to change the equation with the 20 right there. In terms of the graph, it's going to lower the graph. Let's think back on our previous one here. So if he has a maximum of $20, that means he can only spend $20 on french fries. If he only buys french fries, he can spend 20 french fries, right? 20 french fries for $1 each, that's 20 bucks. If he only buys bus tickets, he can only buy 10 bus tickets, right? 10 bus tickets at $2 each is 20 bucks. And the combination is all that in between. So 8 bus tickets at $16 plus $4 for french fries. We still have the same amount of change, the same rate. It's still going to be what we call a parallel line, but it's a whole lot lower because he has a whole lot less to spend on. This would be a new equation if he only has $20. There you go. So you can see how changing your budgetary constraint is going to cause your graph to change. It's going to cause your equation to change. It's going to cause our table to change as we fill that out too. And if we changed any of these y values, right? If the bus tickets increased to $3, granted, that would change your equation a lot as well too, as we're figuring things out. All right, so what did we just do? We attempted to apply our understanding of linear equations, graphing lines, finding points, organizing the situation, but helped us to think about a budgetary limit and find out what combinations of costs are within our budget limit. Now we used a fun example of Pat, right? Pat buying bus tickets and Pat buying french fries, and it wasn't that complicated. You say, come on, Pat, just go with it. It's not that complicated. You don't need to mathematize all that. However, what if you are a company that produces cars, right? So your income, you sell cars and you generate income from your cars, right? But think of all the things you have to keep track of. You have to pay your workers who are working on the car. You have to pay for all the car parts. You have to pay facility rent. You have to pay for increased technology if you're buying new robots to help fix things. You may have inventory reduction, or you may have a clearance or the sale on your cars. There's lots of factors then that affect your income and affect your outcome and how much you have to work with. And if you're Ford Motor Company, if you're Chevy or something, then you sure want to make sure that you are not going into debt. You are not spending more to build the cars than you are actually making money for the cars. And so you need to know, using math, using budgetary constraints, using graphs and equations, are we on budget? Are we on debt? Do we need to make changes so that we stay within our budgetary constraints? That's how businesses stay smart. They use math to help them maximize their money. All right, so what do? We used creating graphs, used a budget, and kind of used math to help us understand a budget. We represented a budget line with 2 variables, x and y. So we looked at what was changing in a situation and what was staying the same. We predicted what would happen if income decreased or if the price of a good changed. We were able to come up with equations that represented our budget line, and we kind of explained the meaning. We had our budget line, but it made a lot of sense in terms of combinations of what you're trying to sell or make or buy, or etc. All right, hopefully that was a good week one lesson for you. Again, use this as you're working on the quiz. Have fun working on the week one paper pencil problems for this week. Let me know if you have any questions and have fun getting started with Practical Math B.